Welcome everyone. Today we are going to discuss about the chemistry of phosphorus in soil. How the phosphorus is behaving, how it is important, what all the chemical reaction is taking place in the soil, we will see in this lecture. The soil earth crust contained 0.02 to 0.1% of total soil phosphorus. Among that, 30 to 65% of phosphorus available in organic form and 35 to 70% of phosphorus are available in inorganic forms. They are derived from the rock named apatite, that is phosphorus bearing rock. They are available in different form, organic or inorganic, soluble or insoluble. They are very reactive in nature with different ions. They will behave differently based on the soil pH condition. Example, in acid soil, iron and aluminum activity is very high, whereas in alkaline soil, calcium and magnesium activity is high. So depending on the condition or availability of these minerals, the phosphorus availability is questioned here. We will see very elaborately. It is a limiting nutrient in many unfertilized as well as in the acid soil. Before studying this lecture, you should know about the terminologies related to phosphorus. H3PO4 is a phosphoric acid. H2PO4 is monobasic primary orthophosphate. HPO4 2 minus dibasic secondary orthophosphate and PO4 3 minus is a tribasic. This, whenever the hydrogen ion is present, their availability is mostly depending on the acidic condition. When the hydrogen ion is absent in the form of phosphorus, they will be available in alkaline condition. So among all the forms of phosphorus, this HPO4 dibasic HPO4 2 minus is a mostly available form of phosphorus in the soil. Phosphorus as a plant nutrient. After nitrogen, it is very important nutrient. As we have seen, it is most limiting nutrient. It will create a deficiency in plant growth, and this deficiency is very typical, which will produce a purple color discoloration in the leaf, plant leaf, all kind of leaves. The plant use about 5 to 25% of phosphorus, and their function is it is involving in the energy transfer reaction mainly. So adenosine diphosphate, triphosphate, the energy transfer will happen. That's why it is called as energy currency of the plant, the phosphorus. They are also component of amino acids, protein, DNA, and RNA, and involving in cell membrane as phospholipids. There are three different forms of soil phosphorus: soil solution phosphorus, labile phosphorus, non-labile phosphorus. Soil solution phosphorus represent the phosphorus available in soil solution, which is readily available for the plant. The plant can take the phosphorus from this soil solution phase. So it is a direct source. And labile phosphorus, so the phosphorus will be adsorbed, not absorbed, adsorbed on the surface of soil solid, just physical contact with the soil particle. Anytime the detachment will happen between soil particle as well as the phosphorus element. They goes into rapid equilibrium with soil solution. So these both will get equilibrium. Once any soil solution shortage is taking place, immediately it will be refilled by the uh, phosphorus present in labile. So the equal amount of phosphorus will be maintained in both soil solution phosphorus as well as labile phosphorus. That is called equilibrium. So rapidly that filling up process will take place. That is rapid equilibrium. The non-labile equilibrium, they are insoluble portion of phosphorus. It won't involve in rapid equilibrium, but they will release into the labile pool. From the non-labile pool to labile pool, slowly the phosphorus will be released. Okay, so it won't get any equilibrium between these two, or non-labile to soil solution phosphorus. And they are represented by apatite, iron phosphate, aluminum phosphate, and organic compounds. They are non-labile because they are not easily soluble one. So phosphorus soil solution is a available form. Phosphorus adsorbed is labile phosphorus, and phosphorus precipitation is non-labile phosphorus. It is very important part of this lecture because this is phosphorus cycle. Here you can see different colors of component. The green color are components, different components. Blue color input, and orange color is loss of soil, loss from the soil. So among the green color, the soluble phosphorus, as I said to you that soluble phosphorus H2PO4 and HPO4 is an available form of phosphorus. From this, the plant can uptake the phosphorus directly. So the uptaking is one kind of loss, and when we are harvesting the crops, that is another kind of crop loss. Okay, and sometimes the soil soluble phosphorus will get leached because of the unfavorable condition. So this process is called leaching. Regarding phosphorus, this is a very minor, little amount of leaching will take place, not huge amount as compared with the nitrogen. Sometimes the surface runoff and erosion may take place due to some erosion process. The surface soil will washing away. Along with that, the phosphorus also get washed. And this soluble phosphorus, sometimes unfavorable condition comes. It will become a adsorbed condition or non-labile condition. So adsorption and desorption is another process. The adsorption, nothing but the physical contact between the soil particle as well as the phosphorus in the solution. And desorption is just a detachment between these two particles. And another process is precipitation and dissolution. Precipitation mainly happen because of the iron and aluminum oxides in acid soil, and calcium and magnesium in the alkaline soil. So this combination, this reaction, chemical reaction is called precipitation. Precipitation won't be soluble easily. The next one is dissolution. The opposite reaction for precipitation is dissolution, means the phosphorus will be dissolved and coming back into the soluble phosphorus. Okay. So when you are adding a fertilizer or any organic sources, the phosphorus will be directly coming into the soluble phosphorus, either through organic or inorganic. Organic, nothing but microbial plant residues, humus, farmyard manures, many things we are adding plant residues, biosolids. So directly the organic will come into the soil soluble phosphorus. So conversion of this organic phosphorus into inorganic. This phosphorus is known as inorganic phosphorus. So conversion from organic to inorganic phosphorus is called mineralization. Whereas the reverse process of mineralization is immobilization. Conversion of inorganic phosphorus to organic phosphorus is immobilization. Okay. Sometimes when you are putting any inorganic fertilizer such as a single superphosphate, diammonium phosphate, or any primary mineral apatite, they directly bring into the soluble phosphorus, that is H2PO4. Okay, these are all very important cycles. So this cycle has to be remembered always. One by one, we'll see the component. First one is mineralization. Having said, the mineralization is a conversion of organic to inorganic, soil organic phosphorus into inorganic phosphorus. So this reaction is mediated by the enzyme called phosphatase. So here you can see the R. R is a radical. This organic radical, which will be reacting with the hydrogen, sorry, water molecule. The water, the hydrogen will be replaced the organic radical, that is RO, so that it will become inorganic. So this process is called mineralization. The mineralization should happen continuously and flawlessly to ensure the availability of phosphorus to the crops. So there should be a CP ratio, carbon and phosphorus ratio, the ratio amount of carbon to amount of phosphorus in the soil. So it is depending on the mineralization and immobilization process. So if the CP ratio is less than 200:1, the net mineralization of organic phosphorus will happen. And 200 to 300, no gain or no loss of organic phosphorus, nothing will happen. More than 300, net mineralization of inorganic phosphorus will happen. So always the CP ratio should be less than 200 so that net mineralization will be happen. And the opposite reaction of mineralization is called immobilization. So conversion of inorganic phosphorus to organic phosphorus by microbial activities. The phosphorus fixation, the next process, conversion of readily soluble phosphorus into less soluble or unavailable form, means we have seen the precipitation process, that is called phosphorus fixation process. So three mechanisms are there in phosphorus fixation. One is precipitation, second one is adsorption, and third one is anion exchange. We'll see one by one in the upcoming series. Like a precipitation in acid soil, as I told, iron and aluminum activity is very, very high. So this iron and aluminum will absorb the phosphorus to become iron phosphate and aluminum phosphate. It is yeah, insoluble precipitated form. It is very difficult to separate. Okay. Then in alkaline condition, dominant ion are calcium and magnesium. This calcium and magnesium reacting with phosphorus to produce calcium phosphate and magnesium phosphate. These are also a very bound form. So to ensure the availability of phosphorus, we have to maintain the pH in a neutral condition, 6.5 to 7.5. Okay, so that the phosphorus availability will takes place. Otherwise, when it is turned to acid soil or alkaline soil, it will make a biggest problem for the availability. So this is the simple reaction. You are adding phosphate to the soil through the fertilizer or any other source. When the ion is dominant in acid soil, the ion will lock the phosphate ion inside, so it won't come out. So the availability of phosphorus will not be there. So similarly, there is a calcium in alkaline condition. Calcium also lock the phosphorus in their form. So it is very difficult to retrieve the phosphorus from their structure. So this is the equation simply telling this is iron hydroxide. This iron hydroxide react with H2PO4, which is available form of phosphorus. Then the H2PO4 is replacing this hydroxyl ion, and hydroxyl ion are coming out, so that it will become a bound form. Similarly, this is iron, this is aluminum. In aluminum, the aluminum hydroxide H2PO4 is replacing this hydroxyl ion, and hydroxyl ion are coming out. This is the another reaction. You can see this is monocalcium phosphate, CaH2PO4 twice. When it is reacting with calcium carbonate is yeah, alkaline material. When it is reacting with the calcium carbonate, it will become a dicalcium phosphate. This calcium will be added to this calcium, will become dicalcium. When keep on reacting with calcium carbonate, then it will become octa calcium phosphate. Octa means 8. 8 molecules of calcium will be formed. Compound will be formed. So it is very, very bound form of calcium phosphate. It won't soluble easily. Then finally it will become hydroxyapatite. Apatite is an insoluble parent material. This will become hydroxyapatite. It is also a insoluble form. It will become a precipitated one. It is very difficult to convert into a available form. Then adsorption, there is a difference between adsorption and absorption. Absorption means completely sink, completely means completely reacted by the chemical means. But whereas adsorption, ad means in the surface alone, the physical uh, interaction alone will takes place. So it is refers to retention of phosphorus on soil solid and oxides of iron and aluminum. Just a retention of phosphorus. Phosphorus is just sticking on the surface of oxides of iron and aluminum. Then anion exchange. This we have seen already. This is clay hydroxide compound. This compound, when react with H2PO4, it will become the H2PO4 will replace hydroxyl ion, and the phosphorus will retained by these clay molecules. So it is a available form. But at the same time, when the iron and aluminum rich in the soil, when it is reacting, the H2PO4 will replace hydroxyl ion, so that it will become a aluminum hydroxide compound. Okay, aluminum phosphate compound. So it is very, very difficult. You can see the relationship between the availability of phosphorus as well as the pH. So pH start from 3 to 9. Here you can see this zone pH 6.5 to 7.5 is a maximum zone of phosphorus availability. When it is reaching to either side, acid or alkaline side, the precipitation and fixation will takes place, because the phosphorus fixation is very, very high in this region, very, very high, like pH 3, pH 4. When the pH is increasing slightly, it's showing a declining trend. It is very, very important. The phosphorus availability is directly correlated with the soil pH. So it is necessary to maintain the soil pH in a optimum range or neutral condition. Here also you can see different form of phosphorus which is available based on the soil pH condition. So this is neutral condition 6.5 to 7.5, where monocalcium dicalcium phosphate are available. But at the same time, when pH increase towards the alkaline condition, it will become tricalcium phosphate. It won't available. As well as when it is reducing the pH, it will become iron and aluminum phosphate. This is also unavailable. So it is very important to maintain the pH in soil. See the factors which is affecting phosphorus fixation. So first one is nature of clay mineral. There are different types of clay mineral, like 1:1 type or 2:1 type. 1:1 is mainly kyolinite and halloysite, or the uh, uh, minerals coming under 1:1, and 2:1 montmorillonite. Here expanding and non-expanding type of clay minerals are there. But this phosphorus fixation is highly happen in 1:1 type of mineral rather than 2:1 type of mineral. So the 1:1 type of mineral example is laterite soil. In laterite soil, 1:1 type of clay mineral are dominant, so that their uh, phosphorus fixation is very high in laterite soil. Whereas 2:1 type of clay mineral are they are containing in black soil. The black soil has less amount of phosphorus fixation when compared to this laterite soil. Then soil pH, we have seen very elaborately in the previous slides that pH should be maintained in the range 6 and 7, so that the phosphorus availability will takes place. Uh, Otherwise, when it is go beyond these ranges, uh, the the dominant elements will not allow the phosphorus available to the crops. The same way, you can see this bar showing very high, so that this is means in this pH range 6.5, availability is very, very high. Then next, organic matter, soil organic matter. The organic matter, what it is doing during the decomposition of organic matter, the phosphorus availability is increasing. Phosphorus availability is increasing. How it is increasing? During the decomposition process, the organic matter releases some acids, either aliphatic acid or aromatic acid, along with the lignin, citrate, and humate. They are organic acid. Okay, so this organic acid will react with these metal ions, iron, calcium, calcium, magnesium, or metal ion, to form a chelation. CHELATION. Chelation will form. What this chelation is doing? This chelation will make the nutrient available to the crops. Okay. So already in the acidic condition or alkaline condition, the phosphate ion is reacting with this and became iron phosphate, aluminum phosphate, calcium phosphate, magnesium phosphate. It is precipitation in condition. When the humate or any organic acid, citrate or aromatic acid, aliphatic acid, when it is interfering this process in this compound, what will happen? The phosphate ion will get released so that the phosphorus will become available. So it is very good option for adding soil organic matter for the release of phosphate ion from the precipitated compound. You can see the example iron phosphate, aluminum phosphate. This is the bound form of phosphorus. Phosphate is locked with aluminum hydroxide. And when you are adding citrate, this citrate will replace this phosphate ion and the phosphate will get freed. So similarly in iron hydroxide also happening here, iron phosphate also. So the same reaction, the phosphate ion will get released. This process is called chelation. Chelation nothing but coordination between the metal ion as well as the organic acid. Next, concentration of phosphorus in soil solution. So depending on the concentration, if there is more uh, soil solution phosphorus, more availability of phosphorus, and less soil solution in less phosphorus in soil solution, less availability. It is based on the amount, how much amount of soil solution present. Next, soil texture. The fine texture soils, that is clay. Clay is known as fine texture. The fine texture soil can fix more amount of phosphorus when compared to sand and silt. Sand is a coarse texture. This is medium texture. So fine will absorb more amount of phosphorus than coarse texture. How to reduce phosphorus fixation? Liming of acid soil. Liming is liming calcium carbonate. Calcium carbonate is a lime. This calcium carbonate can be applied into the acid soil so that the pH will be increasing. When pH is increasing or attaining the soil in neutral condition, automatically the activity of iron, aluminum will reduced, and so that when the soil attain neutral condition, automatically phosphorus availability will increase. And the addition of organic matter, you know the background of organic matter addition, it will form chelation with metal ions so that phosphorus will become available. And use of complexing agent, nothing but EDTA, DTPA, this kind of, they are artificial chelating agent. So this also will react with the metal ions such as iron and aluminum to release the phosphorus from the precipitated condition. Thank you for your attention. Thank you.